So, what's the difference between the kind of radiation that you see on the TV series Chernobyl, or the radiation given off by a nuclear bomb, and other types of radiation? Believe it or not, radiation is actually present in our everyday life. Well, the key component that differentiates deadly radiation from useful radiation to beneficial radiation is what's called the wavelength. If you were to actually zoom in on a beam of radiation, it would appear almost like a wave that's moving up and down. And what we actually do is we determine the wavelength by looking at the distance between any two peaks. And typically this is really small, unless you have very, very, very long waves, and I'll talk about those in a second. Typically, this is a very, very small length. And so we usually use really small units, either micrometers, and a micrometer is 1/1,000,000th of a meter, so really, really tiny, or nanometers, 1/1,000,000,000th of a meter. So these are really tiny units to quantify wavelength. One other thing I'll say is that us nerds in the meteorology world, and actually in the physics world as well, like to use the Greek letter lambda for wavelengths. So whenever you see this letter, either in this investigation or in anything else in this course, just know that lambda means wavelength. Now, the wavelength of a beam of radiation determines two other important things about it: its frequency and its energy. And the relationship is inverse. What that means is that the longer the wavelength, the smaller the frequency, and the smaller the energy. And this is what really differentiates the type of radiation that can kill you versus the type of radiation that harmlessly passes through your body. Now, that being said, we actually then, using wavelength, we can split radiation up into many different types. And many of these are surrounding you right now. So if you've ever listened to an AM or an FM radio station, that's actually radiation. Those signals are being transmitted to you by way of radiation, and typically very long wave radiation. On the other hand, if you've ever used Wi-Fi or a cell phone, the signal that your cell phone receives is actually what's called microwave radiation. And yes, there's actually a type of radiation, a wavelength of microwave radiation that can cook your food, hence the term microwave oven. And then there's, as we get into shorter wavelengths, there's infrared radiation. So now we're talking about a centimeter to as low as 1 micrometer, which is a millionth of a centimeter, or 1,000 nanometers, or sorry, a millionth of a meter, or 1,000 nanometers. And then there's a certain wavelength of radiation that our eyes are sensitive to, and it's what is called the visible spectrum. And the way it works is going from long to short. Red light has very long wavelengths, relatively speaking, and then as the wavelengths shorten, you go from red to orange to yellow to green to blue to indigo, and then the shortest wavelength is violet. And then from there you go into, you go into ultraviolet, X-rays, and gamma rays. And these are the kind of rays over here, X-rays and gamma rays, that can actually be harmful to you. X-rays have applications, obviously. If you've ever had an X-ray taken of you, they have applications in being able to visualize your skeleton. But too much X-ray radiation can be really harmful for you. Ultraviolet radiation, that can cause skin cancer, bad sunburns, and so on. And then gamma rays, this is the kind of stuff that is emitted from nuclear blasts, radioactive disasters, and so on. So this is the electromagnetic spectrum, and basically the idea here is that that different wavelengths determine different types of radiation. And in the next video, you're going to be surprised to see what emits radiation.